Hi everybody, this is Miss Hendricks here with Precalculus. We're reviewing before Precalculus really starts. So these are some lessons that we're covering in class, and I just wanted to make sure that if you were absent, you were able to get caught up on all of this and everything. So we're going to start off here with taking some notes, just to remember, review what radicals are and how to be able to simplify them down. So if you want to pause the video and write all this down and then start it back when you're ready to work the examples, that will totally work. I'm fixing to do some explaining. So if you want to pause, go ahead and pause, and then start back when you're ready. Okay, so with radicals, there are multiple parts, right? And so you can see them labeled in here. We have this first one here, the little number that's written in the crook of the radical. That is called the index, and it tells you what type of radical you're working with, whether it is a square root, a cubed root, a fourth root, or whatever. You can have all kinds of things be your index. So that's what that is. The number that you see underneath the symbol, the radical symbol, that's called your radicand. The symbol itself is called a radical. Now, a lot of people will say that the symbol is called a square root. Now, that is the case if that's the only thing that's written, but it would be any kind of root. It just depends on what the index is indicating to you. Now, if there's nothing written, that's what you're seeing over here in red. If there's nothing written, it is automatically telling you that that is a square root. But that is only if there's nothing written there, or if there was a 2 there. That's the only time it's a square root. If you see a different number there, you're going to call it something else. Like if it was a 3, you'd call it a cube root instead, okay? Another important note is whenever you see this symbol written into a problem, we are indicating that it is the principal square root. And so the principal means that it is the positive version. So you think about logically, if you're going to do the square root of, I don't know, 9, well, you're asking yourself what number squared equals 9. That could either be 3 or it could be a negative 3. The principal square root here, when we see this symbol, it is telling you that we are going to stick with the positive answer. So if you see that symbol in the question, so the question is asking you to simplify and they use that symbol, we are knowing that we are going to stick with the positive outcome. Okay, there are other situations where that will be a little different, and you'll see that in other videos, but for the purpose of a question like this, where it's written in the problem, we are indicating the positive option. Okay, well, those are the 3 problems we're going to work. I'm going to pull up a different piece of paper so that I can write on it without messing up my notes page. And here we are. So we're going to work these one by one. We're going to start off with letter A. The directions have been to simplify, which means we're not using a calculator, okay? Now, if you do want to get a calculator app, you're welcome to download the NumWorks app, which is a free app. It works exactly like our NumWorks calculators that we are working with in class. However, I want us to make sure that we know how to do this without a calculator because the AP test will not always allow a calculator. In fact, more than half of the test, percentage-wise, does not allow a calculator. Okay, so we're going to make sure that we are okay without it as much as we can. All right, let's look here. Square root of 20. So what we're going to do to simplify this, and you may have seen it done many different ways, but the way I like to go about it is I try to find the largest perfect square that's a factor of this radicand. So what do I mean by that? Well, let's think of a list of perfect squares. Perfect squares are things that when you square a number, you get that answer. So if I square the number 1, 1 squared is 1. So 1 is a perfect square. 2 squared is 4. 4 is a perfect square. 3 squared is 9. 9 is a perfect square. 4 squared is 16. So 16 is a perfect square. And you can list these all day long. All right, I'm not going to do any more than that, but there's an infinite number of perfect squares out there. Okay, and what I'm going to look for is I want to find the largest one that is a factor of 20, and I'm going to use that to break it up. Well, the largest one of these that is a factor of 20 would be 4, all right, because 4 times 5 is still 20. So I have not changed the value. I've only changed the way that this looks by breaking apart the number 20 into a pair of factors, 4 times 5. And the reason I chose that is because I can square root the number 4. We're going to pull the square root of 4 out. The square root of 4 is 2, and 5 stays stuck inside. There's your answer. 2 square root of 5. Done. All right, try letter B. All right, so this one's a little bit different in the fact that we have a number that's written in front of the radical. And what that number is telling you to do, this is not the index because it's not written really little bitty up top, right? It's written real large out in front. And what it's doing is it's saying that we are multiplying 6 times the square root of 54. So we are going to simplify the square root of 54 the same way we simplified the square root of 20. And then if there's a number in front, we'll multiply that with the 6. So I'm thinking about 54 and I'm thinking about factors, and I would like to try to find the largest perfect square that is a factor of 54. And the one that comes to mind for me is 9, because 9 times 6 is 54. I can take the square root of 9 out because it is that perfect square. The square root of 9 is 3. The 6 stays stuck inside. And now I'm going to multiply these two terms on the front. 6 times 3 is 18. We still have the square root of 6, and that is as simple as it gets. Let's try one more. This time, the main difference that we've added for fun here is we've added in some variables. And there are multiple ways, again, that I've seen people do this. I will share with you my way, okay? So the -7, he's gonna stay there, and we're gonna work on simplifying the rest. Now 64 happens to be a perfect square, and since we are taking the square root, that makes things easy. The square root of 64 is 8. Fantastic. But now we've got to figure out how to deal with these variables, okay? So here's the way that I do it. I take the index, which here, I know they don't have it written, but you could. The index there is a 2, whether they wrote it or not. And what I do is I take the variables on these, I take the exponents that are on the variables, and I divide that by the exponent, or by the index. So look here. Okay, let's go ahead and multiply these. -7 times 8, right? That should be what, 56, -56? But then when we square root these things with the variables, I will take the exponent and divide by the index. So look here, a to the third. If I take 3 and divide it by 2, 2 goes into 3 a whole 1 time. And there's a leftover. If you remember back in elementary school when you had remainders, that's kind of what I'm visualizing here. 3 divided by 2 is 1 with a remainder of 1. So 1 comes out, that was the whole, and the remainder was left inside. Look here at the variable b. That one, there is no exponent written, which means it was a 1. They just didn't write it. Well, 1 divided by 2, you don't really get anything out of that. The b will stay stuck. Look at your c. The exponent is a 4. 4 divided by 2 is 2, with nothing left over. So there are no c's left inside. So that is my answer. I'm going to clean it a little bit because I do not like to write those exponents that are 1s. I feel like that's kind of messy. But otherwise, that's our answer. So simplifying radicals, that's what we got. Okay? Next thing we're going to do is talk about some solving. Now, there's not a whole lot of notes to write. However, there are some problems. So if you want to pause the video to write all this out, feel free to do so, and then start the video back when you're ready to solve. So when it comes to solving, these are not crazy complicated questions. However, I am going to run through a couple different ways you can do them. I may just mention in passing and then show you the one that I like. So on A, a lot of people, when I've asked this question in class, probably more than half of the people that I ask tell me that they want to distribute the 3 through the parentheses. And that is an option, but it is not the most efficient method, especially because when you start multiplying, you end up with larger numbers. And if you don't have a calculator with you, right? If you don't have a calculator, then you're not going to be able to do super large numbers as easily. So with that being said, I usually look for a way around using a calculator, and I look around using large numbers if at all possible. Here, it is possible because a different way to do this, rather than distributing, would be instead to divide by 3, because 3 is being multiplied by that parentheses. That would cancel out. 75 divided by 3 is 25. Don't forget about these negatives, guys. Regardless on whether you distributed or not, those negatives are going to be there, so do not lose those. We're going to add 5 to both sides, and then we will divide by a -6 and get your answer. Okay? Easy peasy. Next one. This may feel a little bit more complicated because we see the fractions, and anytime that we see fractions, we tend to start to panic. So if you can remember from Algebra 2 what to do, there may have been different ways your teacher taught you. So I'm going to show you what I would do, but there's a lot of different ways to go about it. And as long as you get the same answer in the end, it doesn't really matter which method you used, okay? What I'm going to do on this one is because two of these fractions already have the same denominator, I'm going to work on forcing this one to have the same denominator because it's the only one not matching. So you've got to think back to 4th grade when you were dealing with fractions and how to get equivalent fractions. And to get equivalent fractions, you just have to multiply the top and the bottom of your fraction by the same value. We need to decide what that's going to be. So if I want this denominator to be 6x squared, I'm going to need to multiply the denominator by 3x. And if I multiply that by 3x, I have to multiply the top by 3x. Otherwise, it's not equivalent. Okay, so see what this gives us. The first fraction is still going to be the same thing, but the second one, you'll have 3x over the 6x squared. Then the next one, we've got 7 over 6x squared. Now notice that all of these denominators are the same thing now. And since they are the same thing, it really makes a nice little property. Something that I can do is just multiply through the whole equation by just 6x squared. Look at what happens. Remember that this is over 1. So what happens here is this 6x squared cancels with the other one. And so you no longer have a fraction here. You have 1 over 1, which is simply 1. Over here on the other side, you can think of distributing this, okay? It would multiply and it would be a part of the denominator up here. But look, if this was 6x squared, I multiplied that up there, it's going to cancel with this guy down there. So really, you're just left with 3x. And the same thing would happen when you multiply to this second fraction. You would have this 6x squared in the numerator. Well, that would cancel with its denominator. So really, you're only left with 7. So the fractions are completely gone. And this problem should feel pretty manageable. I would subtract 7 on both sides, get yourself a -6 over here. And then divide both sides by 3, and you get -2 for your x value. Done. The last thing we're going to review in this video is we are going to review linear equations. All right, so again, I'm gonna say you can pause the video for a minute, get this stuff written down, and once you are ready to continue and try these problems with me, then start the video back. Okay, so yeah, here we are, linear equations. We are working with trying to write the equation of a line in slope-intercept form, which is the whole y equals mx plus b format. Keep in mind your m, that is your slope, okay, and b, that is your y-intercept, okay? So in part A, where they say your slope is -2 and your y-intercept is -6, they're telling you what your m and your b are. So for you to write the equation in slope-intercept form, you're literally just filling in those parts. Instead of putting an m, we're going to put -2, then we have an x. Now I know the equation says plus b, but my b happens to be a -6. So I'm going to go ahead and write it as -6, and that's it. All right. I accidentally started writing on the wrong piece of paper, so just bear with me. I'm going to scooch us over here. I'll white out that part, but I want to make sure I do the rest of this on this other piece of paper. Okay, so the next one. They said that we are going to do the slope of 1/2, and it's going to pass through this other point, -4, 8. This is going to use a different form of a line to begin with, and then we'll rearrange it into slope-intercept form like they want. We're going to use point slope formula. So I'm going to write that down right here in case you don't know it. All right, so the pieces here, we got the slope, which is your m, and the point that they gave us, this is considered the x1 and the y1 indicated in this formula. So we're going to plug those pieces in and rearrange it back into slope-intercept form. So we will have y minus 8 equals 1/2 times x minus a -4, which makes plus 4. Distribute the 1/2 through, so we get 1/2 x, 1/2 times 4 is 2, and then add your 8 over, 1/2 x plus 10. Done. That was part B. All right, the last one I have for you guys is what if instead they give you 2 points that it passes through, but they don't give you the slope? So if that's the case, my first my first tip to you would be to find your slope first, and then you can do the same thing we did on the last problem. So if you don't remember how to find your slope, we can use the slope formula, all right? That is your rise over run, right? You might have heard it that way. But it's also important that you understand the formula, where it is y2 minus y1 over x2 minus x1. It is the change in y over your change in x. So look at these points. We're going to let this one be x1, y1 because it's the first point, and this one be x2, y2 because it's the second point. And technically, it doesn't really matter too much which one was which. Just don't do on accident like x1, x2, and then y1, y2. Like, don't do that. That's really common. But each point has an x and a y, so make sure you're mixing it correctly. So I'm going to plug these things in. y2 minus y1, that is a -4 minus 5. That is over x2 minus x1, so -4 minus 8. And we're just going to keep cleaning that up. I get a -9 over a -12. We're going to reduce that down. 3 goes into, or really a -3 would divide into each of those, and simplify your slope down to 3/4. And now that I know this, I've got my slope, right? Now I can use that and one of my points and use that slope, the point slope formula. So I'm going to rewrite that one more time. Okay, I'm going to use, you might be asking, which point do you use and how do you know which point to use? It doesn't matter, just pick a point. I'm going to go with this one because it is already labeled as x1, y1, but you could pick the other point and it would be fine. So we're going to plug in here, my y1 would be a 5. My slope was 3/4 times x minus 8. All right, clean this up. Now we're going to distribute 3/4, 3/4 x, and then we're going to multiply 3/4 times 8, right? 3 times 8 is 24, divided by 4 is 6. And then we're going to add the 5 over, y equals 3/4 x minus 1. There's your equation. Guys, that is it for this video. I hope that helps a little bit with a few review topics that you will need for pre-calculus. This really all was Algebra 1 type stuff. Maybe some of the solving was a little bit more complicated, but I'm really hoping that jogged your memory and is helping you feel a little bit more prepared to be able to do this stuff for our new material going forward. I will see you all in the next video. Bye.